All right, I just got back from the junk store. I needed to go. And I was just poking around today. I didn't need to go for any particular reason. I just wanted to go. I'm worried it's going to shut down someday, and everything else seems to be shutting down. Fry's Electronics just shut down. And anyway, I found these, and they had a lot of ferrites, but I didn't know they had any iron cores. And these seem to be iron cores, so I'm not exactly sure. I think they're type 45s, which I'm not familiar with the types and stuff. I need to research that a little bit, but I thought it might be fun to just grab some and try to make some balance and some other things maybe for some future videos, just to try to get an idea of how those things work, and then try to make a video on teaching you guys. I mean, I understand the theory of them, but I haven't really actually tried them myself, and different numbers of windings. And I don't know if you can actually measure, if it's easy to measure the impedance changes and stuff. Anyway, I thought I'd get some just for fun. They were 25 cents each. That's a good price. So while I was poking around the store, I found this. Okay, I'll put a picture here. And wow, it was this giant rack, and it looked like something out of a old horror film, right? Big knobs on it and everything. I was like, oh my goodness. I don't know if it was super high voltage inside or whether it was just low voltage, but huge variacs, big giant variacs on it. Oh my goodness, and lots of old school goodness. Probably out of some fab around here in Silicon Valley. They have big power supply stuff. But anyway, I did find something to spark my interest though. I've always thought these were really cute, and I always wanted one, especially since I used to work there. And anyway, I bought a power supply, like I need a power supply. It was $15. Okay, it's 15 bucks, right? But it's super cute. I've seen these before, but they're super rare. They probably weren't, 40 years ago. They were everywhere. I think this one had a cool tag on it. Yeah, on the top here. Let me rearrange the camera here. All right, can you see this? It's all handwritten. It says calibration date 5/3/1966. Next cal service due 11/3/66. Meter reads 1.5% high full scale. Something and 1.7% high full scale I don't know. Anyway, 1966. So it hasn't been caled since then. That's that's amazing. Or that sticker hasn't been taken off at least. Let me rearrange the camera. I'll show you the front of this thing. So there we go. It's the old HP logo, the round circle logo. So that's the original, and probably was designed by Mr. Hewlett himself. Hewlett was kind of the engineer. Packard was kind of the business guy. So Hewlett probably designed that. That's my guess. Now the meter's a little bit funny, but it's got a vibrator pen engraving on the front, EXP. Now that means an expensed item. That means that they didn't amortize it year after year. They just paid for it once and then put it on the book. So it's the expensed item 3098. So I'm not sure who owned this thing, but it's pretty cool. It's got a 10 volt range and a 30 volt range and a voltage adjust. And then it's got able to read milliamps, so 300, 100, 30 and 10. So they're nice scales. So 10 milliamp scale. Yeah, it's nice. And then instead of having a constant current adjust, it has a short circuit current protection. So you can set it to top out at 25 milliamps or top out at 50, 100, or 225 milliamps. So yeah, that's really cool. So I'm really going to be curious to find the schematic for this thing and look inside. So we'll look inside now, but I need to find a schematic for it. And then plus minus and an earth ground, so it's floating. So that's kind of cool. So yeah, let's open this thing up and see what it holds inside. All right, there was 2 screws on the back, and then this thing slides out. Let's slide it out. It's got a tight fit. There we go. There's nothing on the inside. There's the original paint color, kind of a lavender. Interesting. But here's the unit. Little transformer, paper capacitor here, and yeah, it hasn't been touched inside. All original. Made by Paco. Very cool. Very, very cool. And then very clear meter. Nice switches. Oh, look, there's a wire wound. Oh, those are beauties. Oh, we'll get a close-up of those. Those are beautiful. Okay, and let's look underneath. Oh, wow. This is why I bought it. This is just old school goodness. Let's see if I can hold it here. Let me get something to prop it up. There we go. Ain't that pretty? So, well, these guys are pretty old. You know, they might be okay though. I think they don't look okay. I don't know. They might not be. Yeah, these look like they're going bad. Old school diodes. This looks like it's probably a Zener. It's a really weird looking package. I've never seen a package like that before. GE transistors. This is very early vintage transistor stuff. Current limit adjust and voltage limit adjust. So looks like we could do some cal. Looks like there might be a little bit of lacquer put on those to lock down the adjustment. But very cool stuff. I like it. 50 volt DC caps. It says 40 to 50. You would think it'd be one or the other. It says 40 to 50. And these guys are 20 to 50 DC. So again, why have a range? 20 to 50. Very strange. Anyway, I like it. Definitely going to restore this one. I'm not going to turn it on until I replace those caps. We'll take them out. Well, maybe those are good caps to measure leakage on. See how bad they really are. 1966. They've got to be dead, right? They got to be dead. 1, 2, 3, 4, 5, dead. These guys are probably just fine. These guys. And that's about it. And oh, and the big one. I forgot about the big one. The big one is 500 microfarads at 75 volts. And yeah, it's a single. It's not nothing else. So that's going to be, replace that with a really tiny one. That'll be fun. Anyway, let me, oh, and here's the pass transistor, right? So from our power supply series, we learned that, you know, everything goes down to one transistor, right? Like the 2N3055. Well, here's the one transistor right there. He's a big TO3, and it uses the chassis here as the heatsink. So he is a 2N375. A three number transistor. 2N375. Wow. I wonder if it's germanium. Oh my goodness. I don't think so. Oh, there's another adjustment on the side here. There's a potentiometer on the side. Interesting. So I'm not sure what that adjusts. There's a protection diode. Remember we talked about the output having a protection diode on it to make sure if you cooked anything up backwards it didn't blow things up. Well, it's right down there on the banana jacks, a protection diode. And the thing I'm most interested in are these resistors here. I've got to change lenses because this is just too good. Okay, so right across the range switch here, this is the current limit switch, is a hand wound resistor. So if I had to guess, I bet you that HP did this at the factory. They wound their own. So they probably had some lady sitting there winding them and putting them in. That is super cool. So hand wound nichrome resistors. And there's one here for the range for the currents, and there's one over here. This capacitor is in the way, but he does the range for the meter. Maybe we can see it better from this side. Yeah, those are beauties. Those are just beauties. Yeah, you'll see those inside resistor decade boxes and stuff. Those real fancy decade boxes that I have, you'll see capacitors like this in them. Resistors like this in them. Yeah, those are beautiful. And then down over here is that protection diode. And I'll swing it around to this side, just because I have a different lens on, give you a better view of things. Here is that 2N375. I'm going to look that up. That'll be interesting. And there's this cool adjustment over here that's really strange packaging on that one. But let's take a look at the bottom with this lens on. All right, there's the board number. 121559. I was born in 56. This was made in 59, so it's almost as old as I am. That's kind of why I wanted it. I knew this thing was vintage. I always saw it in the... I've seen them around, but never had my hands on one. They're cool. Okay, let me see if I can find a schematic for this thing. All right, I found some documentation. This is the 721A power supply. There it is. And from what I can gather, this is 1959. What I can gather is this is one of the very first transistorized power supplies. And it was, I think it was definitely HP's very first transistorized power supply. And it was low voltage, right? It was low voltage, and so it was meant for transistor applications, for you to design transistor circuits. And that was a new thing. Yeah, it says DC 0 to 30 volts, 150 milliamps. So 150 milliamps, right? Low for little transistor circuits. And let's see, there's a schematic in here. I mentioned before, I thought maybe one of the transistors, since it had such a low number, was maybe germanium in it, and it is. This pass transistor, this 2N375, is a, let's see, I thought I brought out a data sheet. What did I do with those? Oops. There they are. Okay, so yeah, a germanium PNP, good for, I don't know. The part numbers are all kind of funny. They all kind of share part numbers, and I don't know which one goes with which one for the 2N375. I think it's probably one of the oldest ones, so it's probably 40 volts. So it's probably a, let's see here, collector base, 50 volt transistor. It's a 50 volt transistor, 3 amps. That's pretty good. That was really good for a transistor. Very, very good. Let's see, base to emitter. Oh, this is a different, I think this is probably a different 350. Yeah, I think that's the previous page. I don't have the any graphs for this one. And then there's 3 other transistors, and those, all 3 of those are the same. They are 2N508s. 508s. So they also are a, let's see, collector emitter. They are an 18 volt device. and they'll do 500 milliamps. Anyway, so the interesting thing here is these three are all the same. So remember how one of the circuits that we looked at was there were 3 op amps and then a big pass transistor that was a Darlington? Well, 1, 2, 3, that sounds suspicious. Well, this one is an emitter follower, so this one buffers the Zener diode. There's a Zener diode right here, so this is the reference. So there's one op amp, and then this one does the voltage. There's a string here, and this is the voltage adjust, and there's a resistive divider, and that one, that base goes to that, and then this one goes to these shunt resistors, these in-circuit resistors to measure current, so that one does current. So yeah, 1, 2, 3, just like the other one. Now the weird thing about this circuit, and it hurts my head, is that everything is upside down. Everything is regulated on the minus part. So the plus, the plus here on the output goes directly to the transformer, all right? It's the minus that has all of the current measurement and regulation also, all together. And it's a PNP instead of an NPN, and anyway, it's all backwards and upside down. All the biasing on this part of the circuit is at minus 16 volts, and this is ground in the middle. And so, yeah, it's just kind of hard to get your head around if you're used to always everything being positive. But that's what it's doing. The transformer has 2 sections, one section for the high current output, and then one little section over here that runs the DC biasing for all of the circuitry here. So there you go. The cool thing about this power supply that it was sold to the Army, and the Army put a number on it. It's a PP3514, and this is the Army manual. Now the Army manual, the military manuals are always way better than the commercial manuals. So this one talks about everything. So it's a really cool manual, to have. So I think the thing to do is let's rip out some capacitors and get this thing going. All right, here are all the capacitors that I replaced, except for that 500, the big jabber there. I guess we could test him too, but I thought we would test these and see how bad they are. So, can you see that? Is that exposed okay? I can never tell from where I sit. Seems okay. All right, so these are all 40 microfarad. Let's try these out. 41 microfarads. That looks pretty good. Let's test the ESR on them. 0.3. I don't know, that one looks good to me. Test the next one. .48, even higher. ESR 0.25. Looks good to me. 47, 0.26 ESR. These are all good. Who are these? These are Sprague, of course. All right, who's this one? This is 20 microfarads. 20. That one's no good. 1.2 microfarads. Yeah, that one's dead. That one's dead. How about this one? That one's 0.1. That one's dead too. Those are both dead. Those are Sprague. Sorry, Sprague. And this one's a 4 microfarad. This is that really weird little one. Let's hook him up. Yeah, 4 microfarads. 4 ohms. That seems a little on the high side. Probably good that I replaced him. Anyway, I replaced all of them. Where's that big one? Let's see if I can clip onto him. Let's see. Ground is one side, and this is the other side. 500 microfarads and 0.06 ohms. That was probably good too. So 2 out of 7 were bad. And we could probably measure the leakage of these things too if we want to, but doesn't really matter. 2 were bad. Others were good. Maybe after I powered it up, they'd all die. Who knows? And speaking of powered up, let's see if it works. Okay, let's power it on. 4 volts. And it's measuring, this meter's funny. It's measuring 4 volts. Let's see, let's set the meter to 6 volts. And it's measuring 6.6. Here's 8 volts, 8.4, and here's 10 volts. Yeah, that seems to be in the ballpark. 30 volts. So here's 10 volts. I gotta get the parallax right. There we go. 9.5. Let's go to 20. I don't think it'll do much over 21 or something like that. I forget what it's spec'd at. 21.3. So I don't remember what the specification is on this, but it does look like it's working. We can probably calibrate it with those knobs. And this meter does seem wonky. It might need, I don't know if I can open it up and clean it. Might need to take a look at it. The 0 doesn't seem to be in the right place. Let's, yeah, see, 0 doesn't read 0. So there is an offset in the meter. So that's probably why it wasn't reading correctly either. So the meter needs to be worked on, but the supply looks like it lives. Now I'm not sure about the short circuit current. We'll have to put a DC load on it to test that. Can you read that? But I brought it back to life. Like the low scale here. Yeah. So yeah, 0 just doesn't go to 0. Something wrong with that meter. I tried adjusting it with this little thing here, but it doesn't do anything. And there is inside there is a 0 adjustment, but it doesn't reach to the outside, so this is just kind of a placebo. So maybe I can reach inside and fix this thing, and maybe there's some other spring action or something that needs to be worked on, but that'll be the next step. But I think I'll end this video here and see if I can't get that thing to work, and then maybe on the next video test the shunt. But yeah, it is reading high, but I think that's the meter. But it does seem to be stable. Let's see. See, this is why you want the extra digits, not for accuracy, but for relative measurements. You can hit the relative button and you can watch it. You can say, okay, you know, how stable is the voltage right now? You know, is it within 1/100th of a volt, or so that's really what it's useful for. All right. Final update on the power supply. It seems to work just fine. The meter seems to go down to 0 now. I don't know why it wasn't before. I don't know. It's just a mystery to me. Let me hook up a load. Let's see here. All right, let me hook up my load here. I've got my 12 volt LED. So we'll put it on 30 volts. And we'll set this to 12. So we have 12 volts coming in, and we'll set it to maximum current and hook it on. And sure enough, it lights up nice and bright. Put that back there. And then you can put the current compliance to 100. And I think you can see it got dimmer. Put it to 50, the dimmer, and put it to 25, and it's very dim now. And you can measure the, let's say it's at 50, and you go here to measure 100 milliamps full scale, and it's measuring 50 milliamps full scale. So yeah, worked great. Cute little supply. It is constant current when the voltage is quite high, but if you put it on 25 milliamps, and you hook up just a single LED, a 1.5 volt LED, it doesn't work. It'll just crowbar. It'll current limit to 25 and then shut down, but it doesn't do constant current at 25. The offset voltages and stuff in that simple little circuit just can't handle that. If it was but a 12 volt LED, it can handle it because the voltage is up into a range where all those transistors are working just great. But for a three germanium transistor power supply circuit, yeah, it's doing pretty good. It's cool to have an instrument that's all germanium. I don't think I've ever owned an instrument that was all germanium. So yeah, it'll be a proud addition to the bench.